Okay, welcome guys. So in this video, let's talk about a small number theory fact called Goldbach theory. Okay, so let's define Fn to be 2 to the 2n plus 1, and this is called a Fermat number. Okay, so f 0 is 2 to the 0 plus 1, I think 3. And f1 is 2 to the 1, 2 to the 1. Yeah, so this is 4 plus 3, 5. And f2 will be 2 to the 2 to the 2, so it's 2 to the 4 plus 1, so it's 17. Okay, and there is a question that whether this Fermat number is an integer, is a prime or not. Okay, but it's not our case. It's not our concern. Okay, so the theorem says that Fn and Fn, if m is not the same as n, then Fm and Fn are coprime. So basically, they don't have the same common factor. Okay. So to prove it, let's quickly see a lemma. So let's just see a quick lemma. Okay, so lemma, let's see. So lemma will be trivial. Let's quickly see. So lemma is that if you let fn plus k, where k is also k greater or equal to 0, then you can write k plus k minus 1 become 2 to the 2n plus k. Right, so this is 2 to the 2n times 2 to the k. So it's 2 to the 2n times 2 to the. Sorry, I'm writing a. Okay, so this is the 2 to the 2n, 2 to the k, right? So this is fn minus 1, 2 to the k. Okay, so this lemma is just what we want to prove, what we want to use. Okay, so by definition, you see that by definition, right? You see that Fm and Fn are odd. So let's assume that so let's prove. So by contradiction, sorry. So I want to prove by contradiction. So I first assume that there's a prime, right? So there is a prime factor p, such that p divides Fm and p divides Fn. And we know that Fn and Fn are odd, so which tell you that the p is odd. Okay. So we have Fm. Let's say p is odd. So we have Fm minus 1 is minus 1 mod p, right? Because I say that Fn divides p, p divides Fm, right? So Fm minus 1 also mod p. And I assume that m is n plus k, so basically m is greater than n. Okay, so we have these two equations, and by theorem, right? By this theorem, let's say n plus k is m, so we have Fm minus 1 equals to Fn minus 1 2 to the k, right? Mod p. Okay, so but right, but this guy, right? This is minus 1 2 to the k mod p, so it should be 1 mod p. Okay, but now we have this and this, right? So it tells that minus 1 mod p equals to 1 mod p. So 2 mod p is 0. So it tells you that p must be 2, right? P must be 2. But this is contradiction, right? Because I already say that Fm and Fn are odd, so p must be odd. But if you use this lemma and compose with all the things you know, then you get contradiction, right? So contradiction. So Fn and Fn are coprime. Why I keep write things wrong, right? Are coprime. Okay, done. And I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.